Listen, I've got a secret for you. Developers only want one thing, and it is disgusting. All we want is to delete the entire cloud instance and replace it with an M2 Mac Mini running Asahi Linux that sits on the desk in the office. Now, apparently, we can't do that because we need backups, and the office internet is unreliable. Another reason is that you can't scale horizontally when running on just one machine, which is actually a valid point if you have a single-digit IQ score. Horizontal scaling goes hand in hand with microservices, which means that unless you work at one of these 5 companies, there is absolutely no need. You should support multiple instances to deploy without downtime. But other than that, horizontal scaling is useless for at least 95% of people. And the problem is that cloud providers will charge you more for a machine that does less and expect you to just purchase more of them to get a functional product.
This has been manipulated, man.
And I'm going to put my money where my mouth is. I'm going to compare the M2 Mac Mini with the base EC2 instance. Kidding. The internet in my office genuinely cuts out every couple months, so I will have to hold on to that dream a little while longer. Let's compare AWS with Hetzner, a popular VPS or virtual private server from Germany. I'm not affiliated with this company, not in an honorable way, more of like an incel way. If you work for a VPS, please contact me for sponsorship. If you work at some stupid AI company, please stop contacting me because I don't care. We're going to start by comparing the CPU, memory, and I/O speeds of a similar spec dedicated server on the VPS and AWS. To keep things simple, I'm going to use Sysbench to run my benchmarks. Sysbench is a mix of benchmarks that will let me test the raw performance of a computing instances. It's a set of Lua scripts that were initially written to benchmark databases, which we're not going to be doing today, but maybe will in the future. It also has some simple benchmarks that can test CPU, memory, and file I/O. I'm going to test the VPS first, and to be honest, this is a pretty good experience. I had no issues creating an account and immediately logging in. I've heard stories of certain countries being outright blocked from this particular VPS. If that happens to you, my advice is to respawn and hope you get a better starting location next time. They forced me to set up 2FA, gave me a recovery key, and set up payments with PayPal.
Nice.
I create a new project and then use the interface to create a new server. I'm going to pick a shared instance because that's what EC2 uses by default, going for regular performance since it will already be relatively cheap. I can add my SSH key directly from my password manager so that all my computers can already connect. And then I'm going to select Singapore since it's my closest server. I'm going to select 1 vCPU and 2 GB of RAM because I am broke, and I will leave the rest of the defaults as is. My server took a few seconds to spin up, quickly enough that it was done by the time I was finished getting distracted by the storage options. I can spin up a console directly from the browser. But since I only configured login with SSH, I have no idea what the password is. So I'm just going to connect using SSH from my computer and run apt update, upgrade, and install Sysbench. The first benchmark I want to run is for CPU. This is a very simple benchmark that just brute forces divisions to find prime numbers. Obviously, this is not the best benchmark ever, and it won't test all features, but it's simple to run and understand and gives an indication of the CPU's performance. It gives the result in events per second. For this machine, the result was 4,391 events per second. I ran it 4 more times and got an average of 4,352 events per second. I did the same thing for the memory test and got an average of 6,230 megabytes per second. For this test, Sysbench does a bunch of read and writes into memory and measures the time taken. The final test I want to run is for file I/O. This isn't the most useful test since a lot of servers write directly to databases, but it still gives an indication of the quality of the underlying hardware. Sysbench needs to create some files for this test, so I need to run the prepare command before running the run command. This particular test gives different results for reads, writes, and fsyncs, for which I got the following averages. On the AWS side, getting started is also very easy. I already had an account because everybody makes mistakes, and spinning up an EC2 instance is surprisingly simple. That's because we haven't delved into the atrocity of serverless computing yet. AWS has many more availability zones than the provider I used. But the beauty of using a VPS and actual servers is that there is no lock-in. So if you need to go to another region, you can always just use a local VPS. I select one vCPU and 2 GB of RAM, just like I did on the VPS, and create a new EC2 instance. I used the same Linux distribution and ran update, upgrade, and installed Sysbench just like I did before. I was hot micing while running this benchmark, so you can hear my live, unedited reaction of the moment I saw how much slower AWS is.
Sorry, what?
That's right. You get to pay almost 3 times as much for less than a quarter of the performance. I actually couldn't believe this, so I went back and checked that I selected the correct vCPU on the VPS. AWS is 20% as good, coming in with an average of 895. Memory is somehow even worse, getting a result that was 7.74% of the VPS. But file I/O was comparatively okay, coming in at 77% of a VPS. But keep in mind, this is still costing 3 times as much. I knew AWS would be worse, but I didn't expect it to be this bad. But people don't really use EC2 anymore. So in the interest of giving AWS the best chance at success, I'm going to use the more expensive, serverless ECS Fargate to run the same set of tests. This is how I've most commonly seen companies deploy their services to AWS, but this means that my happy days of running Linux commands are over. To deploy to ECS, I first need to create an ECS cluster, which just didn't work the first time because CloudFormation is stupid. Once the cluster is actually created, I need to deploy a service to that cluster. The service needs a task definition, which will be used to spin up tasks within that service. I set my task definition to use the same 1 vCPU and 2 GB of memory we've used everywhere else. Now the task definition needs a container image, but I can't just upload one. I have to go to ECR and create a new repository to host my image. Once I've done that, I can add my image, but not through the UI. I have to install the CLI on my computer, but there's no API keys associated with my account. I need to go to the IAM service and create a new user, then create credentials for that user. Whatever reason you have for creating credentials, AWS will tell you that this is wrong and you're not supposed to do that. But I don't care because I just want to get my service up without using yet another stupid 3-letter acronym. Then you attach policies to that user, and now you can finally push a Docker image to use with AWS. Simple enough, right? The UI gives no indication as to what is costing you money or not either. I spent a little bit of time tweaking my image so that it runs all 3 tests and then crashes, which will spin up another tasks and run the tests again. Now I can upload my image to ECR, finish creating my task definition, and create a new service in my ECS cluster. Now I can check the tasks logs to see the results. You might notice that these logs are a bit confusing to read, and that's because they're printed from most recent to least recent. But new lines within the same log are printed least recent to most recent, and there is no separation between groups of logs. New lines on the same log and separate logs altogether all have the same thin grain line to separate them. One log with multiple lines is read top to bottom, but 2 separate logs are read bottom to top, but you can't tell what's a single log and what is multiple. I'm sure you can pay for CloudWatch or something to make this experience ever slightly less terrible. CPU performance on ECS is a little better, coming in at 23% of the VPS's CPU performance, but you are now paying 6 times as much. Memory improved massively up to 80% of a VPS, and file I/O is even closer at 84%. One thing that was strange was that the ECS tasks were far less consistent than both EC2 and VPS. While all other tests were within 3% of their averages, the ECS tasks had fluctuations of 18% from the average for the CPU, 12% for the memory, and 6% for the file I/O, even with just 5 runs. And I have to remind you that this is 6 times as expensive. If you want something that's still only a little bit more expensive, but still slower, AWS will let you pay for a volatile ECS instance that may die at any moment and be unavailable for extended periods of time. You can pay more money for less performance and no availability. Where do I sign up? And don't forget to delete the ECS cluster, service, tasks, ECR repository, and images so that you're not charged for the rest of your life. But it gets even better. If you remember, when we configured the VPS, we created a shared instance. It's not clear to me, although it definitely should be when you're paying what you are, but some of the AWS documentation seems to indicate that ECS uses dedicated resources. So to create a fair comparison, let's check out dedicated instances on the VPS and compare two instances with roughly the same cost. Or at least that was the plan, but I honestly don't know how to give ECS a fair shot in this. A dedicated server with 2 vCPU and 8GB of RAM is still twice as cheap as the 1 vCPU ECS task we tested before. To get the same price, I need to jump up to the 4 vCPU and 16GB of RAM. It's as if ECS is priced in such a way that it will scale down to 1 or 0 vCPU when not in use, and only charge you for what you actually use. But that's not how it works. If I want 4 vCPU, I pay even when it's idle, and you can't even scale vertically at all within the same service, since services are locked to a single task definition. Scaling dynamically horizontally isn't ideal either, since the services take a few minutes to come up. The only way to save money here is to anticipate when your load will be higher and scale horizontally ahead of time. But you can only create more tasks with the single definition defined for that service, so this ends up being ridiculously expensive. According to their own calculator, getting the same spec machine that cost me $49 a month on Hetzner would cost $144 a month. Although this isn't very clear, because it's hard to figure out how much you'll actually be spending, even using the calculator. And the underlying hardware would still be slower. I spun up a bigger VPS server with 4 vCPU and started benchmarking when I realized that I'm actually a moron and that this is a single core test. So I ran the tests again with 8 threads and got 10 times the performance of a similarly priced ECS task. You might think that this is unfair and that AWS should also be run with multiple threads enabled. And I agree. But when I did that, the ECS task ended up performing even slower, so I think it's best if we leave it alone for now. So to summarize, if you have $50 American, you can either buy an ECS task or buy a dedicated server that is about 10 times faster, but AWS will generously let you scale horizontally, so that when your app is under load, you can pay for more terribly overpriced machines. You would have to spend $500 a month and get 10 tasks running before you would ever need to think about your dedicated server. And if you ever did reach capacity on the VPS, you can easily scale vertically and horizontally as you wish. Load balancing is easy, even on dedicated servers. And this isn't just theory. Lichess supports 5.2 million chess games per day on a single dedicated server, because that's the most efficient way to do it. It's not just cheaper and easier to manage, it's also faster. It's amazing how much nicer your infra life can be when your compute actually works for you, instead of falling over its own incompetency whenever it's faced with any sort of meaningful load. This is not the industry standard because it is the best by any meaningful metric. This is the industry standard because they have the biggest marketing spend and the prices to cover that marketing cost.